wanted to give you a little bit of help on manipulating chemical reactions, and I actually am removing the chemistry from it to some degree to show you that we really can treat reactants and products on either side of the arrow just as placeholders or just different shapes, for instance, is what I've got shown here. So if you think about the chemicals in a chemical reaction as just different shapes, for instance, then we can write reactions that show a square turning into a triangle and two pentagons, and another reaction showing a circle turning into a diamond and a pentagon. These are totally made up. It works. When we have chemical reactions with double-headed arrows, we describe them with equilibrium constants. So I'm going to describe the equilibrium constant for the first reaction as K1 and the second one as K2. A lot of problems in chapter 14 ask you about what happens to the equilibrium constants when you manipulate reactions and start combining them. Let's talk about how to think about manipulating and combining them. Here's an example of the type of problem that you might be asked in chapter 14. You have all these ingredients from the first two reactions that are showing up in the final reaction, but you don't necessarily know where it came from. The question usually is going to be something like, what is K for this reaction? It could be another version of a similar question, but this is a good one to start with. The way I look at these final reactions is by trying to figure out where things in the final reaction could have come from. So let me show you what I mean. Here's this final reaction, and it's got a square in it. So the first thing I ask myself is, what is my source of squares? I look at my first two reactions and I only see a square on the left-hand side of my first reaction. That's my first clue that my final reaction must result from adding my first reaction into it, but I can't manipulate my first reaction in any way if I want my square to be on the left-hand side. Does that make sense? The next thing I have in my final reaction are two diamonds. So I ask myself, where can I get diamonds from? I look at my first reaction. There are no diamonds. I look at my second reaction. Here's a diamond on the wrong side. That's my next clue that my second reaction probably has to get manipulated somehow. What if I flip it around? If I flip it around, then my diamond, my source of diamonds, is giving me diamonds on the left. Well, I know that's what I need, so that's good news. When I change this reaction direction, I need to change the equilibrium constant that describes it. Prior to this, my reaction had diamonds on the right, and my K2 was my equilibrium constant. Now I've decided I need to think about my diamond being on the left, which means my equilibrium constant is inverted. The other funny thing about this reaction down here with the diamonds is that I actually need two diamonds. So what happens if I multiply my second reaction by 2? And I have to do that to everything in the second reaction. I may regret putting that 2 in there. There may have been another way to go, but this is kind of the way I'm going to proceed through these brain teasers and see whether or not it's going to work out. Remember, when I multiply by 2, or any coefficient, I'm going to raise my equilibrium constant to that coefficient, so I'm squaring it. So now I have kind of a plan. I want to see whether or not it's going to work out with the other things shown. So here's a pentagon up here that's in my reaction that I think I need to use to get my diamonds. And there's no pentagons down here. That's kind of a problem. Let's keep going and see where I get circles from. I'm going to get 2 circles now. Do I want circles? Yes, I want circles, and I want them on the correct side, which is the right. So I'm starting to feel like I might have something set up correctly. So if I were to add these 2 reactions, I would write everything on the left-hand side down here on the left-hand side of the final reaction. Everything on the right-hand side would get repeated down here, except for things that show up on both sides of the arrows. And that's how I'm going to get rid of my pentagons. I have a pentagon, 2 pentagons given here, but they're on the left-hand side down here. So the sum of the 2 reactions above the line is the reaction below the line. What is K for this reaction? It's the multiplication of these 2 equilibrium constants. I modified my second equilibrium constant as I went. So now that I'm summing my reactions, all I need to do is multiply the two equilibrium constants together. The second one, for the second reaction, got modified as I was kind of playing around with it. Hope this helps you see that this is not as much about different chemicals as it is about finding sources of stuff. Take care. Bye.